And now for some spirited fun. On Tuesday, Markforged launched the Mark X, an industrial-scale 3D printer that allows engineers, manufacturers, and designers to print strong and precise carbon fiber parts for robotics, automotive parts, molds, and other industrial applications. The Mark X is a fiber composite 3D printer with a large print volume, 330mm by 250mm by 200mm to be precise, while the footprint allows the printer to still fit into your shop. What I found interesting was the Mark X's in-process laser inspection and 50-micron surface finish, which makes it easier to print usable parts. The laser sensor is attached to the print head to scan parts at any point of the process to make sure that tolerances are being met. And part quality is improved by including encoders on the print head, silent stepper motors, and a high-stiffness Z-axis motor. The printers run on Eiger software, a Google Chrome-based cloud solution that allows operations managers to oversee and monitor multiple printers at the same time. Earlier this year, if you remember, Markforged received $20 million in Series B funding, and it appears as though they've put it to good use. According to the company, the Mark X will ship in Q4 of this year at a cost just under $70,000 US. $70,000 US. They're sneezing and itchy. The space station has a dust problem, which, I mean, when you consider the fact that Chinese engineers may have lost all control of their space station, might not seem like that dire of a situation. But still, our astronauts' eyes are itchy. They're itchy. Here on Earth, our dust settles, causing matrimonial games of chicken across the globe, but in zero gravity, it remains airborne and sets off our astronauts' allergies. They're sneezy and itchy. Well, a team of researchers at Colorado State University, working with Pittsburgh-based RJ Lee Group, have created the TPS-100, a portable air quality sampler that could, as early as next week, be up at the International Space Station for 32 days detecting dust particles. The project is a low-cost, low-risk experiment that will characterize airborne particles and, ultimately, help develop a permanent dust-sweeping solution that works in low gravity. The hope is that the TPS sampler will give NASA a clearer understanding of the space station's air quality, with the goal of increasing astronaut safety and wellness. The TPS can collect particles down to the nanometer scale, which is 1,000 times smaller than the smallest particles already identified. Hopefully, after a month in space, this device can help the space station pass your mother's white glove test for years to come. He's just a menace with that thing. Dirty. They're sneezing and itchy. Finally this week, GM revealed the Chevy Colorado ZH2, which the company says is the most extreme off-road capable fuel cell powered electric vehicle that it's ever made. The ZH2 is 6.5 feet tall and more than 7 feet wide, and it's built on a stretched mid-size pickup chassis. It rides on 37-inch tires, and the US Army will test its modified suspension in extreme field conditions next year. It also hopes to find out whether or not hydrogen-powered vehicles are a viable option for military missions. The vehicle features an exportable power takeoff unit, which allows users to remove the fuel cell to power applications in remote locations. GM and the US Army Tank Automotive Research Development and Engineering Center, or TARDEC, collaborated on the Colorado ZH2 and went from contract to concept in less than a year. GM and TARDEC have fuel cell development labs that are only 20 miles apart from one another in southeast Michigan. And calibration testing will continue at GM's Milford Proving Ground into early 2017, when the vehicle will be turned over to the Army for a year of field testing. I'm David Manti. This is Engineering by Design. I'll get you.